Scientists at GT Advanced Technologies are developing an exciting new material, and what you see here is a paper-thin sheet of pure single crystal sapphire. Now, sapphire is second only to diamond in material hardness and durability, and because of these remarkable properties, it has long been recognized as the ideal material for many window and cover applications. GT is the world's leading supplier of tools which are capable of producing large, high-quality single crystals of sapphire, and we have an aggressive program to reduce the cost of crystal growth and expand the capacity for fabrication so as to meet the growing demand for sapphire windows. We are also developing a process called proton-induced exfoliation, or PIE, which enables us to produce super thin layers of this single crystal sapphire. These layers can then be bonded to less expensive material so as to provide the properties of sapphire but at a lower overall cost. So what we do is take a thick wafer of the sapphire and irradiate it with a beam of high energy protons, which are hydrogen ions. These ions penetrate to a precise depth below the surface of the sapphire wafer, and they form a layer of small microbubbles of hydrogen gas. The wafer is then heated and the surface layer separates or exfoliates to produce a thin layer with a precise thickness equal to the depth of the original implanted hydrogen. Now, because the layers are so thin, the PIE process can be repeated many times so that multiple high-quality layers can be exfoliated from a single starting wafer. This proton-induced exfoliation process uses a unique variation of the ion implantation process, which is used routinely in the manufacture of silicon integrated circuits. Now in its fourth generation, the GT Hyperion 4 implanter has been designed specifically for the production of sapphire lamina. The first key component is the ion beam generator. The Hyperion 4 uses a much higher voltage to accelerate the hydrogen to a high enough velocity so that they penetrate to the required depth below the surface. In fact, it is capable of producing hydrogen ion beams at energies up to 2 mega electron volts. The beams produced are also very intense, with currents up to 50 milliamps. These high currents are required to meet the productivity and cost objectives of large-scale manufacturing of sapphire lamina. In fact, this combination of high energy and high current makes it 10 times more powerful than any existing implanter on the market today. The accelerator is packaged in a sulfur hexafluoride high-pressure tank. This pressurized gas is a very good electrical insulator, and it enables operation at these high voltages. After emerging from the accelerator section, the beam is focused and deflected through 45 degrees by an analyzing magnet which filters out all unwanted ions. In so doing, the beam transported to the process chamber is greater than 99.9% pure. Before entering the process chamber, the beam passes through a novel magnetic scanner. This scans the beam in both horizontal and vertical directions. In this way, the protons are very evenly distributed below the surface of the sapphire samples with a uniformity variation of less than 1%. In summary, the Hyperion 4 proton implanter has demonstrated an unprecedented level of power and productivity. And it enables us to exfoliate multiple thin slices of high-quality sapphire from a single bulk wafer.